Time dilation is a fascinating concept from Einstein's theory of relativity, describing how time can pass at different rates depending on factors like relative velocity or the presence of a strong gravitational field. There are two primary types of time dilation: special relativistic time dilation and gravitational time dilation. In special relativity, time dilation occurs when an object moves at a speed close to the speed of light relative to an observer. For example, if a spaceship travels at a significant fraction of the speed of light, time for those on board the spaceship will pass more slowly compared to someone at rest. This effect is mathematically described by the Lorentz factor, where the closer the velocity gets to the speed of light, the more pronounced the time dilation becomes. This phenomenon has been experimentally confirmed using precise atomic clocks placed on fast-moving aircraft or satellites, which show measurable differences compared to stationary clocks on Earth. Gravitational time dilation, on the other hand, is explained by general relativity. Time runs slower in stronger gravitational fields. For instance, near a massive object like a black hole, the intense gravity causes time to dilate relative to an observer further away from the object. This effect is significant in extreme conditions, such as near the event horizon of a black hole, where time could appear almost frozen to a distant observer. On Earth, gravitational time dilation is much weaker but measurable. For example, clocks at sea level tick slightly slower than those at higher altitudes because of the difference in gravitational potential. Both forms of time dilation highlight the relative nature of time and how it intertwines with space and gravity. These concepts are not just theoretical, they have practical implications, such as the necessity of accounting for time dilation in GPS satellite systems to ensure accuracy. Time dilation continues to be a cornerstone of our understanding of the universe, challenging our intuitive notions of how time operates. Thank you for watching. We have some amazing videos coming up, so stay tuned and make sure to hit the subscribe button.